Now let's continue with the critical thinking of 3D geovisualization. Okay, the next disadvantage here, the next problem here is called a symbol viewpoint dependencies. It's pretty straightforward. For example, about this 3D visualization, right? If you look at all those traits, you will find out that they are pretty fake. Why is that? This type of visualization happened a lot in 3D video games, maybe 30 years ago. Maybe not 30, maybe 20 years ago, okay? When our software and hardware was not powerful enough. These traits are fake because they are simply combination of two 2D images. If that's the situation, when you're looking at these traits from different directions, you will see different things. You will see different shapes, right? So it means that in 3D, this is just an example. In a lot of 3D geovisualizations, old ones and new ones, you need to be very careful about your viewpoint, the position of your viewpoint. If your 3D visualization is static, okay, consider your viewpoint, and you should consider that this viewpoint cannot be changed, right? What can be seen by the users? If this geovisualization can be rotated, when your users are rotating your GeoVis, what will they say? Are they going to collect incorrect or inaccurate information, right? Okay, so this is a problem. Next one is not about geo visualization. It's about 3D visualization as a whole. Is it useful? Is it necessary all the time? Um, uh, because sometimes if you want to implement 3D visualization, you need to what? You need to use a lot of resources. Okay, let's start. So the technology I want to mention here is called stereopsis. Okay, is a term that is most often used to refer to the perception of depth and three-dimensional structure obtained on the basis of visual information. Um, in general, stereopsis is trying to simulate our binocular system. Why can we use our eyes to perceive distance and shapes correctly in real world? Because although the distance is pretty short, there is distance between our two eyes, which means that when we're looking at something, we're looking at that thing from two directions. And this difference of direction, difference of distance creates 3D what? 3D perception. Stereopsis is trying to do the same thing. You may have seen this before. It's called ViewMaster. Okay, so when you are wearing this pair of goggles, two cameras photograph the same image from slightly different positions. Be careful with this. Slightly different positions. This pair of goggles, ViewMaster is trying to simulate that we're looking at something from two different directions in front of our two eyes to create these images. So you will feel that there is this 3D environment you're immersed in, but you're not actually. And another example would be this. It's a 3D glasses for 3D movies. If you have ever watched a 3D movie 10 years ago, say that, you would probably have seen this type of glasses before. We have two glasses with two lenses with different colors. They are filtering out different colors to create this stereopsis, to implement stereopsis to simulate our eye system. But the problem of this type of glasses is that you cannot tilt your head. If you do that, 3D image, 3D effect will disappear. That's the reason why today, when we're watching 3D movies, we have this type of glasses. they are using polarization to filter out vibrations of light on specific directions and let the rest pass through the lens to create 3D environment, 3D effect. Okay, so the advantage here is very obvious. The colors of the movie will not change dramatically when, like when you are wearing that pair of glasses with different lens of different colors. But another advantage is that today you can tilt your head and the 3D effect will not easily disappear. I mean, if you tilt dramatically, it will also disappear. If you have ever seen a 3D movie before using this type of glasses, you will know what I'm saying here. But yeah, again, it's using another method. We call it polarization to create stereo optics. And it's pretty. 3D environment is pretty, especially when we're using it for entertainment. However, it's pretty hard to create. You have to be careful with a lot of things, right? Variations in lightness and color and hue. A color is actually a combination of hue, grayscale, right, and grayscale, and which means you have to invest a lot of time, labor, and money to create very cool, high quality 3D visualizations. That's the reason why I mentioned before that this has nothing to do with geography, because when we are doing GIS projects, when we are doing research with GIS and 3D visualizations, usually we don't have the time and resources to create very expensive 3D environment. Okay, and yeah, we have other methods to do the same thing, to create this fake 3D environment. It's not called 3D, it's not called stereo optics anymore. It's simply called stereo. Okay, okay. So here, let me say, here we have this example here, right? So we are looking at this castle, pretty beautiful castle, and you should have this 3D, I mean, perception that the mountain is very far away, then the castle is closer to you, then this small building and the trees here, they're closest to you. This implementation is pretty simple. You simply use 3 layers. Each layer is an image. The first layer is the image of the mountain. The second layer is the image of this castle. The third layer is the rest. And you move them along the same direction using different speed. Then you have this stereo fake 3D effect. Okay, it's also called parallax. And here is another example. You see it a lot in video games, especially pretty old-fashioned video games, right? We have sky as a background layer, these mountains, I would say that the same mountains as the second layer, and the grass as the third layer closest to you. You move them on the same direction using using different speed. You will have this 3D fake 3D effect, right? And the next problem here is called z-axis contention. So because we're talking about 3D environment, there is the third dimension or the third axis. Usually it's called z. And sometimes z is just too busy to us. When we have the third dimension, we usually get very greedy. We want to put a lot of other variables along this axis, but it's pretty hard to implement that. Usually the third dimension, z-axis or z, simply z, is used to address time or height. But how about addressing them together simultaneously? Or you want to even address more using this axis. It's just too busy. And sometimes if you are too greedy, you are adding too many variables into your 3D visualization along the axis. It's a pretty bad idea. Okay, here is an example. It's a 3D environment showing the trajectory of a burglar from this location, right? From this location, and he's searching. This is the trajectory, right? And the burglary committed, and go to another place, searching, travel to another search location, searching, and yeah, decide to rob somebody or steal something, and travel somewhere to start a search, and then at the end of the day, he also needs to go back home to sleep, right? So this third dimension here is used to address the trajectory of this thief, of this burglar, in a day. So the third dimension here is for time, and x and y obviously they're for latitude and longitude. And we can see a lot of black, I mean not black, red dots on the ground on this reference map. It's a projection of all those green dots, blue dots, and yellow dots, right? So here, the third dimension has been used for time. How about elevation? What if I want to know the elevation of this area simultaneously? It's pretty hard to do that. It's pretty hard to do that. So it may be prohibitively complex if the terrain was also visualized in 3D, right? That's a method to address elevation simultaneously. You can make the surface 3D. You can make the surface 3D. So they now can be used to address time and elevation simultaneously. But what if more? What if more? 3D symbols can be used for half a dozen variables, but some datasets have scores or hundreds, I mean, a lot of variables. If you if you want to put not even a dozen of them, if you want to put more than 2 of variables along the axis, your geovisualization, 3D geovisualization will be just too complex for your users to read. So it's not a good idea. It's called dimensionality curse. You have the third axis, but you cannot, I mean, abuse it. Say that, okay? And sometimes 2D display that techniques may be more effective. As long as these techniques, they're good enough. 3D is not necessary. It's not necessary. And sometimes if you want to create very complex 3D geovisualization, GIS software is not good enough. You need to ask for help from computer science, from other disciplines, from other software, which means more resources, right? So step back and ask some relatively simple questions before creating 3D geovisualization. Is the visualized thing free from distortion, bias, or other visual error? Are the display methods used appropriate for the task at hand? Would any patterns hidden in the data be more evident if 2D visualization methods were used? Are the visualization techniques being used best suited to the current user? So you want to get back to this very simple but fundamental and important questions, and then decide if you should use 3D geovisualization, okay? Do not use 3D only because you can do it, okay? Understand the principles and limitations of 3D visualization and know how to make effective choices in harnessing the power of available tools for your needs. In other words, I mean, 3D world is more real. 3D world is more complex, but it doesn't mean that you should always use 3D technologies to finish your geovisualization, okay? And here is a pretty good Q&A I found in a forum. I think the answer here is very decent, very frank and useful, and you should remember. So the question is, the question is this: I'm looking for any published research paper regarding the significance of 3D GIS analysis or geodesign, which shows that 3D analysis provides us with much more reliable and closer to reality results than 2D analysis. Okay, here is the answer I like. Geospatial analysis is a very broad field of research and application. You will use the tool you will need. 2D, 3D, or even adding more dimensions into your geovisualization, into your analysis. These tools will depend on the purposes of your research. And the phrase closer to reality in GIS analysis will depend on the quality and certainty of your data. Then the dimension and in a second degree on the analysis methods you will use, okay? So quality, certainty, or in general, we say quality and uncertainty. We'll talk about uncertainty later. So in general, the situation, I mean, the status, I mean, let's just say that the data is the most important part of your GIS applications and research. And you should ask those questions I listed before implementing complex methods like 3D geovisualization. If they're necessary, obviously do it. If they're not, if they are using a lot of resources, your time, your money, even more, you need even more people to finish the project, you should consider if this is necessary. Okay, 3D is beautiful, but we have discussed so many disadvantages of it, and it's not always a good choice. And here, Google Earth now is very well supporting 3D geovisualization. And if you're trying to make a 3D geovisualization, you can go to this video here. I've created hyperlinks here. Go there and start from Google Earth. It's a pretty good starting point for 3D geovisualization. Okay, so that's all I want to talk about 3D geovisualization. And thank you.